Okay, so we want the area here. We go back up to our formulas, which we should have on our help sheet. Should need to be there. And we know that this area formula has to be the length surrounding the angle. So we're just going to pop that straight in. Right. So 2 lengths angle in the middle. We're just going to pop that in. You can follow that along. When we look at B, right, we don't have 2 lengths from the angle in the middle. We've got all 3 lengths. So that means we actually have to find one of the angles. So we're going to use the only way to do that is using your cosine rule. Now you can't use your sine rule because we don't have a known pair. All right. So 3 lengths. Pick an angle, any angle. Let's just go with that one at the top. All right. So that means if we're using our cosine rule, it means that that's our opposite there. So we've got 18 squared equals 14 squared plus 16 squared minus 2 times 14 times 16 times cos theta. And now we're going to use our wonderful algebra to get theta by itself. So this whole, right, negative blah, whack it on the other side. So 2 times 14, I'm not even bothering working that out. Right, that comes on the other side. I've still got my 14 squared plus 16 squared, and then I subtract my 18 squared. Now you're more than happy to actually write this formula down and know how to use it, but on the given formula sheets in year 12, they don't give that to you. So I'm old school. I like to use a bit of algebra. So to get rid of times all of this, we divide. Right, and now to get rid of the cos, we are going to cos to the minus 1 of all of that. If you like to use that formula there, right, just make sure your B and your C, they're the 2 lengths that surround the angle that you're trying to find. Okay. You could by all means have found this angle or this one. That's okay. You'll end up with the same answer in the end for the area. You'll have different angles, but you'll end up with the area the same. So if I now wanted to find the area, it would be a half times the 2 lengths that I've got surrounding. So it's 14 times 16 times sine of 73.4. Okay. Next one, the following triangle is a running track. Determine both unknowns. So their angles here, right? You can see straight away that we have a pair. So because we're using pairs, that goes to our sine rule. Okay. Let's go for theta first. Okay, because we've got a known pair and then we've got its opposite length there. So that means start with your unknown upstairs. So we've got sine theta over 5 equals sine 100 over 8. Okay, stop the video and see if you can solve that yourself. Okay, hopefully you agree with that. And of course, now to find alpha, we don't need to do any more trig because we know that there's 180 degrees in a triangle. So we've used up 100, then we've used up the 38. Oops. That was a bit silly. So alpha will be 180, take 100, take 38. Now, what do we want? The perimeter. So clear off, any of the stuff. You can pop any other information that you have into your diagram. Sometimes it helps to draw it clearly. So if you want to, we can just draw this again. So we've got 100. That one was 38. This one was 42. And what else? We have 8 and 5. And we want our last length here to get the perimeter. So I'm going to be going with, well, you could either use your cosine rule, right, because you've got 2 lengths and the angle in the middle, or you can use your sine rule again because we've got known pairs. So I'm going to go with the sine rule. Okay, so that means our unknown keeps it upstairs, so it's going to be x over sine 42, and that's going to equal the known pair that we have, 8 over sine 100, or you could have gone 5 over sine 38, but we did round that off a little bit, so I'm going to stick with what we've got, okay? See if you can solve that yourself. Hopefully we agree with this. Do make sure that you don't just pop your answer there. You show you're working, even though it's something so simple. If you got a wrong answer somewhere around the place, at least I know you've got the right process. I know it's obvious, but, you know, stick with it. Okay, with these questions, you've got to make sure that you label your diagram well and you put your thinking down over here. All right, so you've read the question already. How high is the hill? So make sure that we are putting the X there, or you can leave it as the H. That's all groovy. And we're looking, and if you look at the bigger triangle, all right, there's only an angle, and that's it. We don't have the whole length, so no right angle is going to help there. If you look at the little one, same thing, you've only got an angle, so that's not going to do it. All right, obviously with this X that we're trying to find, really we either need this length or this one. Now this has got nothing connected to it, so I'm going to try and get this length here. Okay, so I'm going to pop that in as a Y, and already it's starting to look pretty good because you can see that I've got its opposite angle. So now I'm thinking, let's hit the sine rule with this, but I haven't got any other information, right? But what can I use here? So this is 180 degrees in the straight line. Okay, so you should be able to get that angle. And then you've got 180 degrees in this bigger triangle, which means you should be able to get that angle. So go ahead and try and do that. So stop the video and we'll see what happens from there. Okay, so hopefully you agree that that's 15 degrees. And even if you didn't, you know, you put something in there. If it was the wrong degree, doesn't matter. You just keep on going and I can follow. Now what I've done over here is I've just taken this triangle and I've written out all the information that we have, and I can just see the triangle. So you can see really easily now that I can find that Y value, okay, by using the sine rule. So, and then once you've got that length, you can now use your normal right angle trig on that triangle to find the height, the X that you wanted. So go ahead and do that, and then you can compare your answers. So hopefully we got Y was that. And then I'm putting that into this triangle here. Okay, and we use normal right angle trig. So opposite side, hypotenuse side. I mean, you could use your sine rule as in this one here, but right angle is easier. So I've got H over 1811.6. And we end up that it's 11.33 meters. Okay, but it comes down to make sure the diagram's labelled, make sure you put as much information and you do something because we want to give you marks. Okay, with question 4, it's a simple pop it into your calculator. So to convert radians to degrees, we times by pi over 180, so we get 7 pi on 4. It's that easy. And of course, to go the other way, we just times by 180 over pi, or as I like to do, I just replace pi with 180. And it will do it for me. So check your answers there. That's pretty straightforward. Right, solve the following using your calculator and rounding your answers to 2 decimal places. Right, we've got a couple of options here. Let's go into our normal calculator mode. We can go, options, calc, solve n, so F5. And then we type in what we see now. First thing we want to do is notice that we are in radians. So I have to actually go and change, yes, I am in radians. You can just type in cos x, right? Shift to decimal, so equals negative 0.3, close, I'm not going to close my bracket just yet because I'm going to say comma x, comma between 0 and 8, close your bracket, equals, yes, we know more than one solution exists, and there we have it. So we've got 1.8, what have we got? 2 decimal places, so 1.88. And 4.41. Okay, the other way that you could do it if you so desire is you can go into your grafting mode. Okay, and we will actually graph cos x, and then we can graph negative 0.3. Okay, shift view window, trig, and we can set our parameters here, 0 and 8. Problem with that is, you know, your scale might be a little bit funky, but we can see very clearly, so G solve intersect. That's the one we got, and that's the other one, and you know, you might think that's easier to visualize. I do like a graph. All right, so try that with your next question. Right, you can do the same thing. Okay, so I just stayed in the graph function there, type that in. The first thing I will notice is that this 2 out the front is going to increase its amplitude. So when I graph it, I can see quite clearly that it has gone up. I mean, I can go shift zoom auto if I want to, but you can see pretty clearly I've got the intercepts there anyway. So that's all I need. So G solve intersection. Okay, so 0.22. We won't waste time. You can see 3.66 and 6.5. So know how to use your calculator. It's really going to save you a whole lot of time. All right, find exact solutions. Same thing. You can actually do this. Obviously, the calculator graphing mode won't give you the exact solutions, but you can, like we did before, options, calc, solve in. This will give you exact with these ones. However, it did say use an algebra approach. So here we go. First thing we want to do is we want to get sine x by itself. So the root 3 goes on the other side. It becomes minus root 3. We divide by the 2. Okay, and this is one of those ones where we have exact values for. So you should have your bookmark handy. All right, we've got this, and we can see sine of root 3 on 2. So pi on 3 is our working angle. So we've got x is pi on 3. I'm not bothered about the negative because that's going to come into play now. We go in which quadrant is sine negative. Remember, your sine is your y-axis, and so it's negative downstairs in those quadrants. I know it's been a while since you've done this. It's 0, pi on 2, and pi, and then 3 pi on 2. So we've got pi plus a third of a pi. So therefore, x is going to be 4 pi on 3. A whole pi plus another third is 4 pi on 3. And then we've got 0 or 2 pi. So 2 pi's take a third of a pi. That will give us 5 pi on 3. All right, again, if you're not good with your fractions, feel free. You can use your calculator, but this just gives it to you in exact form. Okay, now we're happy. It's our domain of 0 to 2 pi, so we're done here. We do the same thing with b. We're going to have cos x, get rid of the take 1, add 1, get rid of the times 2, divide root 2. Okay, and this time we find our working angle is pi on 4. Okay, so 1 on root 2 or root 2 on 2, pi on 4. It's positive cosine. Remember, cosine is now your x-axis, and it's going to be positive here and here. So we've got 0 plus pi on 4, and then we've got 2 pi take pi on 4, which means cosine, or x, sorry, is pi on 4 and 7 pi on 4. Okay, so I do it. 2 times 4 is 8. So 2 pi will be 8 pi on 4. Take away 1 pi is 7 pi on 4. But if you don't like fractions, right, just use your calculator, right? 2 take 1/4. Don't make your life harder than it needs to be. Now, this becomes plus k lots of 2 pi, which I should have put on the first one up here, but because my domain was there, I didn't bother. And that means we can do multiple laps. So plus k 2 pi. Now we just said over here 2 pi is 8 pi on 4. So I just have to keep adding that to each one of these. So I put my pair, and now I'm going to say what's 1 over 4 plus 8 over 4. So that's now 9 pi on 4. And then I add the same thing to this one. So 7 plus 8 is 15 pi on 4. And then I add it to this one. And I just keep on going and going, right? but I cannot go for longer than 4 pi. And this is clearly above 4 pi because 16 pi on 4 will give me 4 pi, so I stop. If instead of being 0 here it was minus 2 pi, then instead of adding on 888, I could also subtract it. Okay, so if I was going the other way, 7 take 8, I could also have minus pi on 4. 1 pi take 8 is minus 7 pi on 4, and so on. Lucky for us, we didn't have that. But, yeah, just getting carried away. Right, onward. Oops, and sorry, don't forget, check on your solving here. So we'll solve n. We will type in root 2. Oops, that's type. Cos x take 1 equals 0. Okay, comma x, comma 0, 2, oops, it wasn't 2 pi, it was 4 pi. Close your bracket. Yes, yes, yes. And those are the exact solutions that we've got. So definitely check. Just because it says algebra doesn't mean you can't use your calculator to check. Population in thousands. Okay. So I read the question, find the small. Because it said sketch, I'm going to go straight to drawing my graph first. We know that this stretches it out. So just because of the 2, I know it's going up to 2 and down to minus 2. And then this add 5 is taking that 2 up to 7. And so when I go to my calculator to pop it in, I already know some of my values. Okay. All right, so we're popping this in. Pi t3. Now, your calculator doesn't realize that x means time, so we just keep it with the x. It's been very nice to us and has given us a domain. So pop that in. I, again, like to go back to standard. I'm going to make that 0 now. I might just have a little buffer. We can change your y min and max automatically because we just talked about that. We know that the maximum, right, it's 2 plus 5 is going to go up to 7. But my calculator is so good, I don't have to. So it's already got that. I could if I wanted to do shift zoom auto, but you know what? Let's leave it. So find the initial population. That is when time equals 0. Just in case I have popped something incorrectly into the calculator, I am still going to write this down so I maximize my marks. But in reality, all I'm doing here is I'm going gsolve. I can either say ycalc when x is 0, right? That's 5, or you can say gsolve, that is also your y-intercept. Okay, so we've got 5, and what was it? Was it in thousands? In thousands. So we've got 5, i.e. 5,000. Find the smallest and largest population sizes and when they occur. So gsolve max. Right, so 1.5, sorry, the max is 7. So the max is 7,000. And when does it occur? I'm going to write this when x is 1.5. Sorry, go away e. When x is 1.5, and we can see up here as well, there's another occasion. So move your arrow across and 7.5. So now we've got what's on our calculator. We have a look. C is the number of weeks after initial, so after 1.5 and 7.5 weeks. And then do the same for your minimum. So gsolve minimum now, press F3, 4.5, week 3. And a bit naughty, I guess I should put t instead of x, right? Find the intervals when it exceeds 6,000. I'm going to exit that, and I'm actually going to type in 6,000 as my horizontal. Oh, nothing happened, and I go, of course, because it's not 6,000, it's 6. Okay, gsolve intersection, so we'll write down between 0.5 and 2.5. So we'll write that between 2.5 and 5 using nice maths notation, and also between 6.5 and 8.5. What was that again? 6.5. So we've got 6.5, and I guess we'll put 8 because we've got our limit here of 8. We've sketched the graph, so you just need to draw that nicely. I wouldn't put this wasted space down here. Okay, so leave that as T, as P, and I'm running out of time here, so you can sketch that. I'll leave that to you. Okay, the period. So we can see here, remember, if it's got y equals sine bx, your period is going to be 2 pi over b, and that is the same for cosine. Remember, when it's tan, that's when we have, it's not 2 pi, it's just pi over b. All right, so for my period here, it will be 2 pi. The amplitude is your a value, so it's 3. We'll do the same thing down here. What is your period? So this time it's going to be 2 pi over 2, so it's just pi. And your amplitude, there's a big old 1 there. We don't put -1, we just put 1. Okay. Please, again, feel free, use your calculator to help you with this. But we know that this stretches it out by 3, and then this lifts it up by 1. So coming back here, we're going to go exit. Get rid of that. Oh, what did I do? Okay, delete, delete. We can pop 3 sine x plus 1. All right, I'm going to go back to my view window, back to standard. Actually, probably better to use trig. I'm going to say 0. We've got, what are we going to? 2 pi. So question's really nice. It's actually given you the scale even. So minimum is minus, we'll go -3, and the maximum is 5. So there you go. And you can sort of say, G solve y-intercept. So 0, 1. Okay. And you can help yourself along the place to find out how it goes. Okay, but that's it. Determine the equation formula if the amplitude is 5, so that's your a value. There is a downward shift, so downward shift, that's your minus, that'll be d, will be -4. A shift to the left of pi on 2, so that means c will be plus, and the period is 8 pi. So we've got period is actually 2 pi on b. We want to find our b value, so our period is 8 pi. A little bit of maths here. Unknown is downstairs. Do the switcheroo, so we get b is 1/4. So therefore we've got y is 5 sine 1/4 x plus pi over 2 take 4. Okay. Right, we've got sine is 4/5. Use a 4-quadrant diagram to find the exact value of cos and tan. So I'm going to go with sine is opposite over hypotenuse. So this is my x, opposite hypotenuse, and this is a 3, 4, 5 triangle. I could use Pythagoras to find that, but we should know our basic 3, 4, 5. Right, we've got pi on 2 and pi. That means we're talking about this quadrant here. And so we can now say that cos, we know, is adjacent over hypotenuse, so it's 3 over 5. And tan is opposite over adjacent, so that's going to be 4/3. But we have to consider the sine. So in this quadrant here, right, your cosine, remember, yes, SA, TC, but I'd rather you go, this is your cosine axis, and on the left it's negative. And tan here, sine is positive, but cosine is negative, so that will also be negative. If it is now in the 3rd quadrant, Okay, so this one, cosine is still negative, but tan is now positive because you've got a negative divided by a negative, and negative makes a positive. Okay, so, and sine will be negative. So sine x will be negative 4/5. Cos x is still negative 3/5, so unchanged. And tan x is now positive. And make sure you do explain your reasoning, all right, as I just said. Okay, and without using a calculator. Now, just because it says you're not allowed to use a calculator doesn't mean you can't. So sine squared, that actually means sine 2 pi over 3 all squared plus sine 11 pi on 6. Okay, so if you didn't want to use your chart, a little bit of a cheat, no one's going to know. Sine 2 pi over 3. Right, so that becomes 2 times root 3 over 2. Plus, what is sine of 11 pi on 6? And that's minus a half. Okay, so we get root 3 minus a half, and you can leave it like that.